moving on to the Vernier caliper. So Vernier caliper is the precise measuring instruments available in our workshop. So here I have shown one of the example related to the Vernier caliper. So herein you can see that before I move ahead, let me talk about the specimen that I actually wanted to measure the dimension. So herein you can see in the figure 3, I wanted to measure this hollow cylinder specimen dimension. So one is the inner radius, one is the outer radius R1, and the, I would say, height, which is the H. So these three dimension I actually wanted to measure using this Vernier caliper. So before I move ahead, so let me brief that. So this Vernier caliper is having external jaws. So for calculating the outer dia or outer radius, I would say outer dia of this particular specimen. So for that, I actually need the external jaws, or suppose if I wanted to measure the internal dia. So for measuring the internal dia, I actually need the internal jaws of this Vernier caliper. And for measuring the depth or height of this particular specimen, this depth measuring blade is required. So this is all about the Vernier caliper different part. So herein you can see that if you closely look at the Vernier caliper, so Vernier caliper comprises of two scale. One is the main scale, same as the scale that we actually discussed in previous videos. So herein you can see that I'm having one more scale. So this scale is known as Vernier scale. So zoomed view of this scale is shown over here, and this Vernier scale can actually slide on this particular main scale. So Vernier scale can be easily slide on this main scale, or suppose if I wanted to restrict the motion of this Vernier scale at a particular instant. So how can I actually do that? For that, the locking screw is provided. So now suppose if I wanted to measure how much minimum I can measure using this Vernier caliper. So that means the least count of this Vernier caliper. For calculating the least count of the Vernier caliper, again, because I'm having two scales, one is the main scale and other is the Vernier scale. So these two scales are actually going to I would say, going to contribute into the least count of this Vernier caliper. So the Vernier caliper overall least count would be equal to the least count of the main scale divided by the number of division I am having on my Vernier scale. For main scale, we already learned in the previous video how to calculate the least count of a main scale. So that is equal to the main scale reading, say it is having 0, 1, 2, 3 listed over here, and in between 0 and 1, how many division it is having. So again, it is having 10 division, so it would be equal to 1 mm, because 10 mm divided by 10, it would be equal to 1 mm. So now I'm having the least count of my main scale. If I actually divide least count of my main scale by the number of division on the Vernier scale, so that way I'm able to calculate the least count of my Vernier caliper. So here is the formula of the least count of the Vernier caliper. So it would be equal to the least count of the main scale divided by the number of division on the Vernier scale. So least count of main scale is already known to us by the previous video. So it would be equal to 1 mm. So now if I actually look at the number of division on the Vernier scale, so here is the zoomed view of my Vernier scale. So if I closely look at, so it is in between 0 and 1. How many division it is having? 5. Again, in between 1 and 2, how many division it is having? 5. So up to the 0 to 0, it is having 50 division. So if I divide it with the 50 division, So it would be equal to 0.02 mm. So this much minimum I can actually measure using this Vernier caliper. So this is all about the least count of the Vernier caliper. Now moving on, suppose if I wanted to measure the dimension of a particular specimen, so how can I actually do that using the Vernier caliper? So here I have shown one of the examples for measuring the dimension of a specimen. So herein you can see that I'm having a specimen in between the external jaws of the Vernier caliper. So this is the Vernier scale and this black one is the main scale. So now I wanted to measure the dimension of this particular specimen. So how can I actually do that? So firstly, I have to place my specimen in between the external jaws of my specimen, external jaws of my Vernier caliper. Now herein if I can see that, firstly I have to look at where my zero of the Vernier caliper scale, Vernier scale is actually coinciding with the main scale reading. So I have to look at this black line, black zero line of my Vernier scale, where it is actually placing. So it is just after the 19th reading of the main scale reading. So the main scale reading will be just before the zeroth black line of the Vernier scale. So it is 19. So main scale reading will be 19. Now further for the Vernier scale reading, I have to look at where my black line of the Vernier scale is exactly coinciding with the white line of my main scale reading. So herein you can see that this first black line, if you can look at my cursor, is actually somewhat shifted from the white line of the main scale reading. So further I have to see where it is exactly matching. So this is something I have to see. So this, suppose this hand of mine is the white line of the main scale reading, and this hand is the black line of my Vernier scale reading. So this has to be in a single line. So this is something we have to figure out. So if I closely observe my these lines, so I actually observe that initially the distance between them is high, further it is high, and as I am keep on moving, my distance between these lines is actually reducing. So further if I further see, then at a particular point, which is the sixth uh, line at the 6 on the Vernier scale, is actually directly coinciding with the white line of my main scale reading. So this 6 is actually the Vernier scale reading, and how many division I am having up to the 6. So this is something I have to look at. So in between 0 and 1 I'm having 5 division, in between 1 and 2 again I'm having 5 division. So up to 6, how many division I am having? So it is 6 multiplied by 5. So the Vernier scale reading will be equal to 6 multiplied by 5, that is 30. Now my main scale reading I already read, it is 19, and the Vernier scale reading is 30, and my least count of the Vernier's caliper is 0.02 because it is having the 50 division on my Vernier scale. So that is why the total reading of my Vernier caliper would be equal to the main scale reading, which is equal to 19, plus the number of division where my Vernier caliper scale is exactly coinciding with the main scale reading. So it is the 6 multiplied by 5, that is 30, multiplied by the least count of the Vernier caliper, which is 0.02 in this case. So the answer will be the total reading by the Vernier caliper would be equal to 19.6 mm. So here I'm able to calculate the specimen dimension just after the 1 point of the decimal. So after the 1 point of the decimal, I'm able to measure. So this instrument is known as precise measuring instrument. So suppose after the 2 place I wanted to measure, so this is something also I can do using this vernier caliper. So this is something we can further explore. So that's all about the vernier caliper. In further videos, I'll be elaborating one of the simulator which is available online for the vernier caliper. So that way you will be more clear about how to actually utilize the vernier caliper within the workplace.